going here for Climb Mastery, we're going to go through the Higher Maths Paper 2 for 2023. Go through the full solutions for the SQA Higher Maths 2023 exam. Let's go. SQA Higher Maths 2023 Paper 2 Question 1. Triangle PQR has these vertices. Find the equation of the altitude from P. Well, what they're drawing in, it's a right angle. So if I can find the gradient of QR, I'll know the gradient of the perpendicular. So part A, the gradient of QR. I've got 3 minus 8 on the top over 13 minus 2, y2 minus y1 over x2 minus x1. 3 take away 8 is negative 5. 13 minus 2 is 15. That gives me minus a third. And therefore, the gradient of the perpendicular must be 3, since m1 times m2 equals minus 1. And you always need that statement. So now we can use the point P to get the equation. So P is 5 minus 1. So I can use y minus b, y minus 1 equals 3x minus 5. So y plus 1 is 3x minus 15. And therefore y must be 3x minus 16. And we're done there. Part B, calculate the angle beside PR makes for the positive direction of the x-axis. Well, we know that gradient equals tan theta. So we need the gradient of PR. So let's look at P and R. We've got R, 3 minus 1 on the top, over 13 minus 5 on the bottom. That gives me 4 over 8, which is 1/2. So our tan theta equals 1/2. So the inverse tan of 1/2 equals, using a calculator, you get 26.565 or 26.6 degrees. And we're done there. SQA Higher Maths 2023 Paper 2 Question 2. Find the equation of the tangent with... Find the SQA Higher Maths 2023 Paper 2 Question 2. Find the equation of the tangent to the curve of equation y equals 2x to the 5 minus 3x at the point x equals 1. Equation of the tangent, therefore, we need the gradient using the y by dx, and then y minus b equals mx minus a. So our gradient, first of all, our gradient equals the y by dx, remember. That is 5 times 2 is 10, x to the 4, taking away 1 to the power, and minus 3. So at x equal to 1, our gradient equals 10 times 1 to the power of 4 minus 3. 1 to the power of 4 is just 1, so that's just 10 minus 3, which is 7. Now we need a point. So when x equals 1, y equals, I substitute it in, 2 times 1 to the 5 minus 3 times 1. Remember, using a calculator anytime you want, but that's 2, take away 3, which is minus 1. So our point is 1 minus 1, and our gradient is 7. So we can use y minus b, y minus 1 equals 7x minus a, which is 1. So y plus 1 is 7x minus 7. So y must be 7x minus 8. And we're done there. SQA Higher Maths 2023 Paper 2 Question 3. Integrate 7 cos 4x plus pi over 3 dx. So we're going to use the chain rule here because we've got an inner function. So integrate cos, well, cos goes to sine, using the start of the exam paper. So that integral straight away becomes 7 sine 4x plus pi over 3. But then we need to divide by the inner function differentiated. So differentiate 4x, you get 4. Pi over 3 is nothing, so it's just 4. And then we've got plus c, remember, don't forget your plus c. We could leave it like that, but I'm just going to tidy that up slightly by taking the fraction outside. So we get 4x plus pi over 3 plus c, and we're done there. SQA Higher Maths 2023 Paper 2 Question 4. The diagram shows a cubic with stationary points 2, 0 and 0, minus 2. On the diagram in your answer booklet, sketch a graph of 2 times f of minus x. So let's look at this f of minus x. What that means is it reflects in the y-axis because minus 1 becomes 1, 2 becomes minus 2, and so on. So if I take a note on this here, that -1 will end up over there at 1, and that 2 will end up over here at -2, and this one will stay where it is because it's on the y-axis. But with the times by 2 as well, so on the y-axis, on the x-axis, these are nothing for y equals 0, so they'll not move, but the -2 will go down to -4. So it's a reflection, so you'll end up with this sort of picture through 1. Let me do that more neater on a new diagram. So I've got it sketched out here. So we've got -2, we've got 1, and we've got -4 down here. And we're going to go up and down and back up. And we're done there. SQA Higher Maths 2023, Paper 2, Question 5. A function is defined as f of x is 3 minus 2x to the 4. Calculate the rate of change of f when x equals 4. So again, a power word, rate of change means differentiation, and then just sum in x equals 4. So f dash x, well, it's the chain rule, so I take 4 down to the front, times by 3 minus 2x, take away 1 for the power, which is 3, but then I need to differentiate then a function, which is -2, so I'm timesing the whole thing by -2. So f dash x is -8, 3 minus 2x cubed, because of the chain rule. Substituting in 4, f dash 4 is -8, 3 minus 2 times 4 cubed, that's -8, 3 minus 8 cubed, which is -8 times -5 cubed. -5 cubed is -125. 8 times 125. 8 times 125 is 1000. Minus times a minus is a plus. So there we are. SQA Higher Maths 2023, Paper 2, Question 6. A function f is defined as f of x equals 2 over x plus 3 for x greater than 0. Find the inverse function. So what I usually do with these is I write y equals 2 over x plus 3. Well, there's other ways to do these. And make x the subject. So taking away 3, I get 2 over x. Multiplying each side by x, I get x bracket y minus 3 equals 2. And dividing through by y minus 3, I get x equals 2 over y minus 3. So then I immediately write down my answer. The inverse function of x is equal to 2 over, now just x minus 3. Make sure you do not write at any point swapping these back to y and x, because then you'll get an inconsistent answer and you'll lose a mark. SQA Higher Maths 2023, Paper 2, Question 7. Solve sin x plus 2 equals 3 cos 2x. So it's a trig equation. I'm going to have to expand cos 2x, and I'm going to have to use the sine one. So I'm going to rewrite that as sin x plus 2 equals 3 times. If you go back to the start of your exam paper, cos 2x is 1 minus 2 sine squared x. So then we can start tidying that up. Sin x plus 2 equals 3 minus 6 sine squared x. I'm going to take everything over to the right, because it's going to be a quadratic sine squared sine and a number. So taking the 6 across, I get 6 sine squared x. I've got plus sine x. And we've got 2, then take away 3 is minus 1. And that equals 0. So we want to find how to factorise this, and it will be factorisable. So I'm going to show you a way. I'm just going to kind of write m squared, 6m squared plus m minus 1, so you can see this. That's basically the same quadratic. Now, to factorise that, if I times the 6 and 1 together, I get 6. So I'm looking for numbers that times together to make 6, but add together to make the 1 in the middle. So that could be 6 and 1 or 3 and 2. Well, it's clearly 3 and 2. And how is it 3 and 2? Well, it's plus 3 minus 2 equals 1, and 3 times minus 2 is minus 1. So we can now split the middle term. So we've got 6m squared plus m minus 1 becomes 6m squared plus 3m minus 2m minus 1. And then we just factorise each side. So 6m squared plus 3m. 3m is a common factor. You get 2m plus 1. And you've still got 2m plus 1 on this side because you need it to be the same. And it's just going to be minus 1 then, times 2m plus 1. So factorised, that is going to become 2m plus 1. And 3m minus 1. So then taking this and making it our sign, that becomes double brackets, m is just your sine x. So we've got 2 sine x plus 1, and we've got 3 sine x minus 1. And you might have got to that factorisation just by looking. Great if you can. So that means 2 sine x plus, and that equals 0, remember. 1 equals 0, or 3 sine x minus 1 equals 0. So the left-hand side, sine x is equal to 1 becomes minus 1 over 2. Minus 1 over 2, and the other one, sine x, is equal to 1/3. So we need to do the inverse sine of just a half in a calculator. If you don't know it, it is a calculator paper after all. The inverse sine of a half is 30 degrees. That's the exact value. But we need a cast diagram to pick the correct values because our sine was negative. So when the sine is negative, it's in these two quadrants, which is 180 plus and 360 minus. So our first two answers for the left-hand side, are x equal 180 plus 30, which is 210, and 360 minus 30, which is 330 degrees. Now looking at our sine x equals 1/3, we do the inverse sine of 1/3 on our calculator. And if we do that, we get an answer of 19.47. And again, our cast diagram for that side, this time the sign was positive, so it's just 180 minus it. So our other answers are 19.47, and we do 180 minus 19.47 in our calculator, and that gives us our final answer of 160.53. Or you'd be fine with 19.5 and 160.5. And there's our 4 answers. SQA Higher Maths 2023 Paper 2, Question 8. The diagram shows the curve x cubed minus 2x squared minus 4x plus 1, and the line y equals x minus 5, and with the intersect at minus 2 and 1, calculate the shaded area. Now you can't see the shaded area in this question because of the way it's scanned, but it was the bit in between here. So the shaded area is between our limits of minus 2 and 1. So integral, because it's an area, between minus 2 and 1 of upper minus lower. So our upper is the curve, x cubed minus 2x squared minus 4x plus 1. Take away our lower, which is the curve, the line, x minus 5 dx. So that becomes the integral of minus 2 to 1 of x cubed minus 2x squared minus 4x minus x is minus 5x, and 1 minus minus 5 is plus 6 dx. So we're integrating, so we add 1 to the power, divide by the new power. So that gives us x to the 4 over 4 minus 2x cubed over 3 minus 5x squared over 2 plus 6x, and that's between minus 2 and 1. So now we need to substitute. So substituting our limits, our first limit is 1, so it's 1 to the 4 over 4 minus 2 times 1 cubed over 3 minus 5 times 1 squared over 2 plus 6 times 1. Quickly run out of space, so I'll put my minus here and then put in minus 2 in. We get minus 2 to the power of 4 over 4 minus 2 times minus 2 cubed over 3 minus 5 times minus 2 squared over 2 plus 6 times minus 2. Now usually at this point, depending on the mark scheme, you're only going to get 1 mark, usually more, after you've substituted. So if you get really stuck here, just move on. But let's just try and get it, okay? So that gives us, being very careful, first term, 1 4 over 4 is just a quarter for the first bracket. 1 cubed is 1, so I get minus 2/3. 1 squared is 1, so I get minus 5/2. And plus 6. I'm not going to bother trying to add these fractions. I'm going to use a calculator. Minus 2 to the 4. 2 2s are 4 times 2 is 8 times 2 is 16. So I get 16 over 4, which is 4. 2 2s are 4, times 2 is 8, times 2 is 16, so I get minus 16 plus 16, sorry, over 3, because it's minus times a minus. 2 2s are 4, 4 5s are 20, so minus 20 over 5, minus 20 over 2, sorry, or you could have written 10, and then 6 2s are 12. So now it's calculator time if you've not got me already. Okay, calculator, fraction, brackets and fractions. So you open a bracket, use your fraction button, 1/4 minus, make sure you use the arrow if you have to, minus 2/3 minus 5/2 plus 6. So there's my first bracket. And then our second bracket, I've got minus 4 plus 16 over 3, arrow, minus 20 over 2, arrow, minus 12, close the bracket, press equals. I'm getting 15.75, so I'm going to write 15.75 square units. 15.75 is a fine answer. You can leave it as a decimal, that's completely fine. If you'd done it without a calculator, or your calculator gives you answers in fractions, you may have got an answer over 15 3/4. So you could have got 15 3/4, or 15 4s is 60 plus 3 is 63. 63 over 4 would be another answer. SQA Higher Maths 2023, paper 2, question 9. Express 7 cos x minus 3 sin x in the form k sin x plus a, so the wave function. So let's start off with expanding this. You've got k sin x plus a. So from the start of the exam paper, that's k sin x cos a plus k cos x sin a, and then we're just equating the left hand side with the right hand side from the start of the question. So looking at, if I highlight this, what's in front of sin x? I've got k and cos a, and what's in front of sin x in our question? Minus 3, so I can say that k cos a equals minus 3. Similarly, using a different colour highlighter for clarity, in front of cos x is sin a and k, and in front of cos x in our question is just the number 7, so I can say that k sin a equals 7. So now we can find k. To find k, because sine squared plus cos squared equals 1, if I square both of them, I will end up with k squared. So k is going to be the square root of 7 squared plus minus 3 squared. A bit like Pythagoras, essentially. So that becomes 49, and 3 3s are 9. So k becomes the square root of 58. I would usually use an exact value if we can. And then, because sine divided by cos is tan, I can say that the tan of a is equal to minus 7 over 3, or 7 over minus 3. So I can now work on a. The inverse tan of 7 over 3 is 66.8 degrees. So cast diagram, but it's not the cast on tan, remember, it's the cast on cos and sine, because that's what you started with. So looking at sine first, that's positive. So that is A and S. And then looking at cos, that's negative. Well, cos is negative on S and T. So therefore, the quadrant we want is this one, which is 180 minus. So that means that A is 180 minus 66.8, which is 113.2 degrees. So we've got our A, we've got our K. So to answer the question, it is root 58 sine of x plus 113.2 degrees for our mark. Now part B. Hence or otherwise, find the maximum value of 14 cos x minus 6 sin x and the value where it occurs between 0 and 360. Well, notice 14 is double 7, 6 is double 3, so that is just double this. So I just need to double it. So I can say for part B, if I write it out, 14 cos x minus 6 sin x equals 2 times this, so 2 root 58 sine x plus 113.2 degrees. So for part 1, the max value, well, this is just a graphs question. It isn't a differentiation question. A normal sine graph goes up to 1 and minus 1, but it's been times by 2 root 58. So the max value is 2 root 58. Now we could simplify that by, well, not simplify it, we could have that as a decimal because you're using a calculator if you want, but 2 root 58 is fine. There's no square numbers that go into 58. Part 2, find the value of x for which it occurs. So this x plus 32 is 113.2 is telling you something. The sine x, its max normally appears at 90. If I just draw you a little graph, here's our normal sine graph there. And it goes to 1 and minus 1 usually, but for this one, it's going to go to 2 root 58 and minus 2 root 58. If this hadn't been shifted, this number here, its max, would be 90. But it's shifted to the left by 113.2 degrees. So all I need to do is do 90 minus 113.2. 90 minus 113.2 degrees gives me an answer which is negative. 90 minus 113.2 is minus 23.2 degrees. Well, that's no good because that's negative. I'm now in the left and I want it to be between 0 and 360. So to solve that is, remember, sine repeats every 360. So I'm just going to add 360 degrees and that will give me in the correct range 336.8 degrees, and we're done there. Determine the range of values for which the function f of it. SQA Higher Maths 2023, paper 2, question 10. Determine the range of values for which the function f of x is 2x cubed plus 9x squared minus 24x plus 6 is strictly decreasing. There's actually two ways to do this. Both involve stationary points. If you get the stationary points, you can then examine the graph to see where the derivative is negative, or you can just examine the nature of the stationary points. So let's just look at the stationary points first. Stationary points occur when f dash x is 0. So f dash x gives me 6 2's is f dash x, 3 2's is 6, 6x squared, 2 9's is 18, plus 9 18x, and minus 24. And I'm going to look at that equal to 0 for our stationary points. 6 is a common factor, so I get x squared plus 3x minus 4 goes 0, so double bracket that up. X and x. 4 and 1 make 3, plus 4 minus 1 makes 3, so that implies our stationary points occur when x equals 1 or x equals minus 4. So then there's two ways to go now. I'll give you both options. I'll use the nature table. If you're using a nature table, you'll go along to minus 4, along, and then along to 1, and then along. And then you're just going to examine the derivative. So looking at our derivative, a number before minus 4, let's try minus 5. Minus 5 minus 1 is minus 6. And minus 5 plus 4 is minus 1. A minus times a minus is a plus. So it's positive there. It's 0 here. Between these two numbers, let's just try 0 then. Minus 1 times 4 is minus. It's negative there, so it's still negative there. It's 0 there. And then a positive number like 2. 2 minus 1 is 1. 2 plus 4 is 6. Positive times a positive is a positive. So it's increasing before minus 4. And then it's a turning point. And then it's decreasing. Still decreasing, of course. And then it's increasing. So we could say strictly decreasing when minus 4 is less than x is less than 1 in between those two numbers. Or if you, and that works as well because the function is continuous. If it was discontinuous, you'd be a little bit knackered, but we know it's continuous because it is. Now, if we move on to the other way, we could look at just the graph. So graph of the derivative, we know the derivative is quadratic with station points at minus 1 and 4. So 1 and 4, so 1 and minus 4, sorry. So 1 and minus 4, and it's a normal there. So same idea. That's the graph of the derivative. That's the graph of f dash x. And that's negative below the x-axis, which is down here. So it's between minus 1 and 4. So again, you would stay the same answer. Minus 4 is less than x is less than 1. Either of those options will give you your marks probably. SQA Higher Maths 2023, paper 2, question 11. Circle C1 has this equation and C2 has that equation. Find the distance between the centres for part A. So again, look at the start of our exam paper. It tells us that it's x minus a plus x minus b, y minus b squared equals 37. So the centre of C1 is just 4, opposite of minus 4, and minus 2, the opposite of 2. For the centre of C2, so if we examine C2 first of all, it is minus g minus f, where that is 2g and 2f. So we know that 2g equals 2 and 2f equals minus 6. So g is equal to 1 and f is equal to minus 3. So our centre of C2 is just minus g minus f minus 1, 3. So now we want the distance between them. So it's the distance formula already with Pythagoras. The difference between the x squared plus the difference between the y squared. So the distance is just going to equal the square root of, we've got 4 minus minus 1 squared plus minus 2 minus 3 squared. That is equal to 4 minus minus 1 is 5, so 5 squared. Minus 2 minus 3 is also 5, so 5 squared. Or minus 5 squared if you prefer. 25 plus 25 is root 50. We can simplify that as a surd if we want, or just place root 50 in our calculator if you don't want to mess about with surds. That is a calculator paper after all. But root 25, root 2, root 25 is 5, so we can leave it as 5 root 2, or put it in our calculator. Part B says, hence show that C1 and C2 intersect at 2 distinct points. So we already know that the distance between the centres is 5 root 2. Now, if you had to put that in a calculator, you would get an answer of 7.07. So I'm just going to note that for now. And then for part B, to work out whether they intersect at 1 point, 2 points, or no points, you need to examine the distance between the radiuses. So I'm going to need my radiuses C1 and C2. So the radius of C1 is equal to the square root of 37 because it's equals r squared. The radius of C2 is given by the square root of g plus f minus c. G squared plus f squared minus c squared minus c. So the radius of C2 is equal to the square root of, remember our g and f were 1 and minus 3. So it's just 1 squared plus minus 3 squared. Take away c, which is the number on the end, minus minus 7. So it's minus 7. So that is 1 times 1 is 1, 3 3s are 9, minus minus 7 is plus 7. Plus 7, and 9 plus 1 is 10, plus 7 is root 17. So the distance between the centres is the radiuses is so the radius is C2 is just root 17. And we've got root 37 for C1. So we might as well turn them into numbers and add them together, because if you add up the radiuses and it's bigger than the distance between the centres, it means it touches at 2 distinct points. So illustrating that point, let's say we had 2 circles. You've got 2 options. We could touch like this, or we could touch like that, or I suppose we could be that. There's other options with it internal each other, but that's your main ones. If you look at the centres here, it's easy to see from the ones that don't touch. if that distance there, the distance between the centres, is bigger, that is obviously bigger than the radiuses, so we don't touch. That distance there is clearly the same as the radiuses added together, so we touch on the 1 point. That distance there then must be shorter than the radiuses added together. Or in other words, the radius added together is bigger than the distance between centres. They touch at 2 distinct points. So all we need to do is check what R1 plus R2 is. So R1 plus R2 equals root 37 plus root 17. So you get your calculator out, and that gives you 10.02. So since 10.02 is greater than 7.07, the distance between the centres, the circles touch at 2 distinct points. And we're done there. SQA Higher Maths 2023, Paper 2, Question 12. A curve for which the y by the x equals 8x cubed plus 3 passes through minus 1, 3. Find y in terms of x, or differential equation. I integrate the y by dx to get y, but that's going to have plus c, so sub in the point. So y equals the integral of 8x cubed plus 3 dx. So y equals, add 1 to the power, divide by the new power, so 8 over 4 plus 3x plus c, or y equals 2x to the 4 plus 3x plus c at the point when x equals minus 1, y equals 3. So subbing that in, we get 3 equals 2 times minus 1 to the 4 plus 3 times minus 1 plus c. So 3 equals 2 minus 1 to the 4 is 1. 3 times minus 1 is minus 3 plus c. 3 is minus 1 plus c, so c equals 4. And therefore, we just rewrite our equation with the c replaced by the number 4. 2x to the 4 plus 3x plus 4. And we're done there. SQA Higher Maths 2023, Paper 2, Question 13. A patient is given a dose of medicine. The concentration of medicine in the patient's blood is modelled by C of t equals 11 e to the minus 0.0053 t, where t is the time in minutes after the dose, c is the concentration in milligrams per litres. Calculate the concentration 30 minutes after the dose was given. Okay, so for part A, all we're doing is saying that C equals 11 e to the minus 0.0053, and that's going to be times on the top by 30. 11 times e to the power of, use my brackets, minus 0.0053 times 30, close my brackets, press equals, you get an answer of 9.3829, so 9.38 will be fine. Milligrams per litres, whether or not we'll take a mark off or not for losing the units, you need to get units if you can. Okay. Part B, calculate the time taken for this dose to become ineffective. And it says that the dose becomes ineffective when the concentration force is 0.66. So all we're doing is subbing in 0.66 to here and solving the resultant equation. So for part B, I'm going to write 0.66 equals 11 e to the minus 0.0053 t. So I can divide through by 11 straight away. If I do 0.66 divided by 11, I get 0.06 equals e to the minus 0.0053 t. Take the natural log of both sides. You can either write it as log e or ln. I'm just going to write ln. 0.06 equals ln e to the minus 0.0053 t. So ln 0.06 equals minus 0.0053 t, taking that to the front, ln e. But ln e is 1, or log e is 1. So that means that ln 0.06 equals minus 0.0053 t. And then dividing through by the negative there, I get ln 0.06 divided by minus 0.0053. So just calculator, ln 0.06 divided by minus 0.0053. and we get 530.83 times in minutes, so 531 or any reasonable rounding minutes. Make sure you write your minutes. No need to change that to hours and minutes. Minutes should be fine. SQA Higher Maths 2023 Paper 2 Question 14. The net of an open box is shown. The base is 3x by 2x with a height of h. Find the area of a net in terms of h and x. So for part 1, we've got 3x times 2x for this bit here. And then this will be 2x because it's just going to go up the side with that. So that's 2x. And obviously this is 2x as well. We've got 3x here. And then if you just imagine that over the top or around the front, this will also be 3x. So you've got 3, 4, 5, 6, 7, 8, 9, 10. So it's plus h times 10x. So that gives you 6x squared plus 10hx. And it's only worth 1 mark, so there we are. Part 2, given the area is 7,200 centimeters squared, so the volume is given by this. Well, volume of a cuboid is area of the base times the height. Well, the base is this bit here, which we already know is 6x squared. So that's 6x squared h. But that's got h in it, so we need to get rid of that h. But we already know that 6x squared plus 10hx equals 7,200 from the question. So we can rearrange that to find h. So 10hx is 7,200 over 6x squared. So h is 10hx is 7,200 minus 6x squared. So h is 7,200 minus 6x squared all over 10x. So now our volume is just going to be 6x squared times the whole of that. I've not simplified that yet because I'll just simplify at the end. So 7,200 minus 6x squared over 10x. So that means our volume equals, well, dividing through by 10 first, I think, we'll get 6x squared, 720 over x minus 3/5 of x. So what I've done there, divided this by 10, so it's still over x. And then dividing this by 2, you get 3/5. X squared over x is just x. So now I can expand the bracket. 6 times 720 is actually 4320. Use a calculator, so you get 4320. X squared over x is just x. And then 6 times 3 is 18 over 5. We'll just leave it like that. Yep, minus 18 over 5. And we get x cubed. Part B, determine the value of x, which maximizes the volume of the box. So it's maximize, optimize. Let's go. So for part B, to maximize the box, we need to examine the stationary points. So stationary points occur when the derivative equals 0. So v dash, well, as a function of x, I suppose, is equal to 4320. And that's going to be minus 18 times 3 over 5 x squared. So v dash x is 4320. 3 times 18, 3 tens are 30, 3 eighths is 24, so that's 54. So minus 54 over 5 x squared. And we're going to make that equal to 0. So we can say that 54 over 5x squared equals 4320, just like that, taking that over to the other side. So dividing, timesing by 5 and dividing by 54, I'll do that. So actually 54x squared equals 5 times 4320, which is 21600. So x squared is the square root of, divided by 54 is 400. So x is the square root of 400, which is equal to 20. Now just a little note on this. it's actually equal to minus 20 as well, but you can't have a negative length, so it's only 20 the one we're picking. So it's just 20 we're looking at. Now we just need to check, is that a max or is that a min? So x along to 20 and along, examining the derivative to see if it's a max or a min. Okay, so we need to examine before and after 20, so let's try a number before 20. So let's try 19. 19 squared times 54 divided by 5. That number is smaller than this number, so that minus that is positive. So it's positive before 20. It's 0 at 20. Then if you try 21, the same idea. 21 squared times 54 divided by 5 is bigger than 4320. So 4320 minus that is negative. And therefore, we've just worked out that x equals 20 is a maximum turning point. So the box is maximized by x equals 20. Is it centimeters? Yeah. Centimeter. And we're done there. So you have Maths 2023, paper 2, question 15, the last one. The line x plus 3y equals 17 is a tangent to a circle at the point 25. And it also says the centre of a circle lies on the y-axis. So if we imagine this is a y-axis here, somewhere that centre is on that y-axis. So now it asks us to find the coordinates of the centre of the circle. Actually quite a tricky one, this one, but let's just start dealing with it. Where's our centre here? We know that the radius meets the tangent at right angles. So if I knew the gradient here, I would automatically know this. So let's start on that point. We've got x plus 3y equals 17. 3y then equals minus x plus 17. Y equals minus a third of x plus 17 over 3. The gradient of that is minus a third, and therefore the gradient of the perpendicular is equal to 3 because m1 times m2 equals minus 1. We also know that the centre of the circle lies on the y-axis. So if it lies on the y-axis, it goes along 0. So if I draw an x-axis in, we don't know where this x-axis is, so I'm not going to put it there. That's like our x-axis. It goes along 0 and up some number, call it c. But we know our gradient is 3, and we've got 2 points, so we can use the gradient formula and work out our c. So let's just do that. We've got 0c and we've got 2, 5. So y2 minus y1, 5 minus c equals 2 over 2 minus 0 equals our gradient of 3. So we've got 5 minus c over 2 equals 3. 5 minus c equals 6. So I'll just take the 5 over minus c equals 6 minus 5. 6 plus 5 minus c equals 6 minus 5, which is 1. So c equals minus 1. So the centre of the circle is simply 0 minus 1. And we're done there. This has been Qualifications Mastery with the whole of the SQA Higher Maths 2023 Paper 2 exam. Hope you found that useful and helpful. Take care, stay safe, and goodbye.